SpaceX announced the first human spaceflight mission to explore Earth from a polar orbit. Rockett Lab shipped the next Mars mission spacecraft to Cape Canaveral in preparation for launch. And teams at Starbase continue Starship Superheavy catch simulation tests. SpaceX continues with the Starship pace, with another busy week in both the rocket production and launch sites. Starship 33 continues to be stacked, as only 2 sections remain until the first Block 2 ship is fully assembled. Those sections are the bottom liquid oxygen tank section, slated to have 4 rings, and the aft engine section, which also has 4 rings. This will bring the number of rings for Block 2 Starships to 21, compared to 20 on Block 1 ships. This extra ring and the ability to move the tanks allows SpaceX to add around 300 tons of extra propellant to the vehicle. Starship 30 did more engine testing past week with a spin prime test. This was required after another Raptor vacuum engine was swapped out. Ship 30 is back at the production site on a ship transport stand. Teams is finishing the heat shield work and other final line items on the ship at the Rocket Garden. Flight 5 Superheavy booster still at the company Mega Bay 1 building after completing engines firing testing. The next milestone for this booster is getting its hot staging ring installed. Regarding the readiness for Flight 5, SpaceX posted on social media that Flight 5 Starship and Superheavy are ready to fly, pending regulatory approval. Additional booster catch testing and Flight 6 vehicle testing is planned while waiting for clearance to fly. Ship 31 just recently started getting its heat shield redone, like SpaceX did to Ship 30, which took about 38 days to complete. This occurred after Flight 4 Starship heat shield failing during re-entry. Booster 14.1 was rolled back out to orbital launch pad for more chopstick catch testing. At the end of June, B14.1 was mounted on the OLM and slapped by the chopsticks. This testing was to dial in the speed and control of the chopstick arms before a flight booster came in for a landing. Teams also tested the landing rail system to ensure that the system could take the instant load required. Since those tests, SpaceX has replaced many of the linkages to the landing rails on both arms and upgraded and added more landing rail actuators to both arms. This will help the rails take more force and be more controllable. Another big change is that teams replacing and upgrading the bumper pads used to slap B14.1 in June. While teams had replaced the actuator on the north side arm, crews only upgraded the main actuator on the south arm. So, both arms should be able to move at full speed. With all these changes, teams did 6 tests using both arms coming in for a slap, simultaneously simulating a booster catch, ahead of potentially catching Booster 12 during Starship Flight 5. After completing another set of testing with the chopsticks, B14.1 has been rolled back to the production site. The orbital launch pad B continues progressing, as the tower is 6 modules tall. With the first 6 modules done, the CC-8800-1 crane was laid down and finishing its reconfiguration before being raised again to finish the tower. This week the team's keeping to an impressive pace by rolling out tower sections Module 7 and 8 and stacking them on top the previous sections just over 2 days after it arrived to the pad. The next and final tower Model 9 have scaffolding on top and will be ready for rollout and installation soon. This week, the Roscosmos Progress 89 cargo spacecraft headed to the International Space Station following the launch at 11:20 p.m. Eastern Daylight Time Wednesday, August 14th, 8:20 a.m. Baikonur Time, Thursday, August 15th on a Soyuz rocket from the Baikonur Cosmodrome in Kazakhstan. With around 2,400 kilograms of food, water, clothing, fuel, and equipment for the Expedition 71 crew. After a 2-day journey to the station, the unpiloted Progress 89 spacecraft arrived at the aft port of the orbiting laboratory's Zvezda service module at 1:53 a.m. Eastern Daylight Time Saturday, August 17th, and will remain docked for approximately 6 months before departing for a re-entry into Earth's atmosphere. This is the 4th launch of Soyuz 2.1A rocket and the 7th launch of a Soyuz family rocket in 2024. On board the station, NASA astronaut Matthew Dominic does a wonderful job photographing Earth, as this time-lapse of the moon setting into streams of red and green aurora followed by a sunrise lighting up Soyuz with a light blue. This week SpaceX announced the first human spaceflight mission to explore Earth from a polar orbit. As early as this year, Falcon 9 will launch Dragon's 6th commercial astronaut mission, Fram 2. which will be the first human spaceflight mission to explore Earth from a polar orbit and fly over the Earth's polar regions for the first time. Named in honor of the ship that helped explorers first reach Earth's Arctic and Antarctic regions, Fram 2 will be commanded by Chun Wang, an entrepreneur and adventurer from Malta. Wang aims to use the mission to highlight the crew's explorational spirit, bring a sense of wonder and curiosity to the larger public, and highlight how technology can help push the boundaries of exploration of Earth and through the mission's research. Joining Wang on the mission is a crew of international adventurers. Norway's Jannik Mikkelsen, vehicle commander, Australia's Eric Phillips, vehicle pilot, and Germany's Rabia Rog, mission specialist. This will be the first space flight for each of the crew members. Throughout the 3 to 5-day mission, the crew plans to observe Earth's polar regions through Dragon's cupola at an altitude of 425 to 450 kilometers, leveraging insight from space physicists and citizen scientists to study unusual light emissions resembling auroras. The crew will study green fragments and mauve ribbons of continuous emissions comparable to the phenomenon known as STEVE, strong thermal emission velocity enhancement. On Thursday, August 15th, 9 a.m. Eastern Time, Falcon 9 launched the MAXAR 2 mission to low Earth orbit from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. This is the 16th flight for the Falcon 9 first stage booster supporting this mission. Booster 1076, which previously launched CRS-26, OneWeb Launch 16, Intelsat IS-40E, O3B mPOWER, Ovzon 3, Eutelsat 36D, Turksat 6A, and 8 Starlink missions. Following stage separation, the first stage conducted a boost backburn and returned to the launch site, with a landing on Landing Zone 1 at Cape Canaveral.
For the Falcon 9 booster on your screen right now. And there was that sonic boom.
Stage 2 FTS. Stage 1 landing light deploy.
After launch, the satellites were placed into separate orbits. The WorldView Legion 3 satellite ended up in a circular 450 kilometers altitude orbit at 45 degrees inclination, while WorldView Legion 4 satellite is in a circular 700 kilometers altitude orbit at the same inclination. The WorldView Legion 3 and 4 satellites, totaling 1,500 kilograms in mass, will join WorldView Legion 1 and 2 in orbit as part of the MAXAR Digital Globe constellation of Earth observation satellites. The Indian Space Research Organization, ISRO, has flown the last certification mission of its new Small Satellite Launcher. The Small Satellite Launch Vehicle, SSLV, launched successfully on Friday, August 16th, at 3:47 Universal Time. The rocket lifted off from the first launch pad at the Satish Dhawan Space Center on Sriharikota Island in the Bay of Bengal on India's southeast coast. EOS-08 is ISRO's latest Earth observation satellite. The primary objectives of this satellite mission include designing and developing a microsatellite, creating payload instruments compatible with the microsatellite bus, and incorporating new technologies required for future operational satellite. The satellite payloads include electro-optical infrared payload and global navigation, satellite system reflectometry payload. The spacecraft mission configuration is set to operate in a circular low Earth orbit at an altitude of 475 kilometers with an inclination of 37.4 degrees, and has a mission life of 1 year. This flight is the first SSLV launch of 2024 and the third overall flight of the year for ISRO.
4, 3, 2,
On Friday,
1.
August 16th at 11:56 a.m. Pacific Time, Falcon 9 launched Transporter 11, SpaceX's 11th dedicated smallsat rideshare program mission with 116 spacecraft on board from Space Launch Complex 4E at Vandenberg Space Force Base in California. The European Space Agency's Arctic weather satellite is on board this flight. The 120 kilograms microsatellite, built by OHB in Sweden, will take advantage of its sun-synchronous orbit to monitor weather in the Arctic and improve forecasts for this region. This satellite is a prototype for a possible future constellation of satellites to improve weather forecasting in Earth's polar regions and elsewhere on our planet. Also on board the vehicle, 2 NASA small satellite. The Pathfinder Technology Demonstrator missions, PTDR and PTD4. PTDR will demonstrate monolithic ultraviolet and shortwave infrared optical sensing from space, PTD-4 will test a very high and low power with deployable solar array with an integrated antenna called LISA-T. This was the 12th flight for the first stage booster supporting this mission, which previously launched SDA-0A, SARA-2, and 9 Starlink missions, and the 80th Falcon 9 launch of 2024. This week, Rockett Lab packed and shipped 2 Mars-bound spacecraft to Cape Canaveral, Florida in preparation for launch. These twin spacecraft for the Escape and Plasma Acceleration and Dynamics Explorers, ESCAPADE, heliophysics mission were designed, built, integrated, and tested by Rockett Lab for the University of California, Berkeley's Space Science Laboratory and NASA. Upon arrival at NASA's Kennedy Space Center, Rockett Lab team members will transfer the spacecraft to a clean room for post-transport inspections. Following thorough checks, the team will commence preparation for fueling the spacecraft in anticipation of their upcoming launch on Blue Origin's New Glenn rocket. Rockett Lab continues making the world's largest carbon composite rocket, Neutron. Recently, the company shared this automated fiber placement machine that will produce all of Neutron's largest composite structures in Neutron's production process. More than 100+ engine and stand readiness tests have been completed at Archimedes Engine Test Site in Mississippi, including multiple hot fires and engine install and operation systems validated.